All right, hello everyone. I'm going to give it just a couple minutes for people to finish arriving. While people are arriving, we'll see if you can find the chat window. That's going to be our primary way for you to submit questions or make comments or things like that. I will be periodically answering questions during this webinar today. I may not do it in live and real time. I'm going to stop at a few times and kind of round up all the questions. Also be aware that there's a slight delay. So your chat will come in real time, but my video responses is delayed. It has to go through YouTube. It takes, I don't know, 10, 20, 30 seconds. So even if I tried to do like live responses, there's going to be a little bit of a delay. So just bear with me there. It's going to be good. I've got a great webinar up today. We're going to be going over Rust errors. It's going to be super fun. I've got details about a sale here at the end of the webinar, so hang on for that if you want to get some good deals. Yeah, super excited. I'm looking at the chat right now. I see some people are joining from Poland, Brazil, California, Kiev, so Ukraine. Wow, that's amazing. Looks like we've got an audience from all over the place. Super exciting. Just going to give it like another 30 seconds or so for people to connect, and then we'll get going. So I hope you are all really into Rust. I hope you have an IDE or editor already set up. Maybe you've been learning Rust. Maybe you're already a professional developer that's been using Rust on the day job. Maybe you're new. Maybe you're not new. Maybe you need a little bit of refresher. Maybe you just want to learn some stuff about error handling. See if I know any tips or tricks that could be useful. I promise you this is going to be a useful course today. It's going to be fun. If you really want to learn, participate in the exercise, do the exercise, do some stuff yourself, integrate it into your own projects. It's going to be good. All right, I think we're going to go ahead and start now. Well, so let's switch this camera. Okay, let's get this up. Okie dokie. All right, everyone. Welcome to today's webinar, Mastering Error Handling in Rust. I'm Nathan Stocks. I've spent over 25 years working as a software developer at both startups and at large companies like Amazon and GitHub. I've been teaching Rust professionally since 2018. I've given conference talks, half-day workshops, corporate trainings, online courses, webinars like this one, and more. In this webinar, I am going to go over how to handle Rust errors, including different approaches for libraries versus applications, when to panic and when to return an error, how to create your own error type, and how to use the anyhow and this error crates to handle errors more ergonomically. This is all pulled from a single section of my Ultimate Rust 2 course. You should have at least a basic grasp of Rust for this webinar, but if you don't, or if you need a refresher, go take my Ultimate Rust crash course. Today's webinar will be fun and informative, and you can just sit back and watch it if you like, but you will learn more through hands-on practice. There's an errors exercise that we will be going through together today. I encourage you to go through that exercise yourself as well, and try some of the things that we will learn today in your own Rust projects. The exercise is stored in a Git repository at github.com/cleancut, that's my username, mastering_errors. CleanCut's my GitHub username, mastering errors is the name of the repository. You will need to clone this repository and open it in your favorite IDE or editor, and then open the source lib.rs file and follow the exercise instructions. If you didn't catch all that, no worries. I'll go over it again when we actually get to the exercise, and we'll run through it together. I will periodically pause and answer any questions you might have, so please feel free to submit your questions and I'll make sure to get them answered. After all, one of the best things about live events is that I can answer your specific questions as they come up. Now let's dive in. Before we really get going, I'm just going to check and see in the chat, see if we have any questions already. Someone's from Hong Kong, that's cool. All right, we've got no questions to start with, so we'll just dive right in. All right, sorry about that. I had to take down the slide to see the chat window. Got to figure out a solution for that so I can see them both at the same time. Let's talk about how to create your own error types. For both this section and the error handling section that follows, there's a lot to be said, and it can be helpful to hear about different approaches to the problem. So after you finish this webinar, I encourage you to go watch Jane Lusby's 2020 Rust Conf session entitled Error Handling Isn't All About Errors. There's a link in the README of the repository. So let's start off by talking about how to make your own error type for a library that you intend to publish or use in something else. There's a bunch of things to remember about creating errors, so I'm going to start assigning them some numbers so we can refer to them. Thing to remember number one, errors should be enums. Technically, anything that implements the error trait can be an error, so it's possible to create an error struct. But I'd advise you start with enums. Stick with this rule, it'll save you some grief early on. Here's an example of an error enum. I call it puzzle error. You don't have to include the word error in the name of the enum if you don't want to, but if it isn't obvious that your enum is an error, adding the word error to the end will definitely help. Number two, you should group your errors as variants of as few enums as makes sense. Here I have two actual error conditions to worry about. I've grouped them both into the puzzle error enum because it makes sense. As you discover new errors, you would add more variants. It should take something pretty significant to justify creating a second error type. Just having a larger number of variants isn't a good reason to split them apart. I mean, look at standard I/O error kind in the standard library. The variants that handle file, socket, and pipe errors are all grouped together because they're all similar enough that it makes sense, and this is a big long list. But there's a separate enum for errors that occur when dealing with integers because they don't make any sense to group together with the I/O errors. So think hard about how you group your errors into enums, but don't be afraid to make a long list of variants if it makes sense to have them in the same enum. Number three, you should only return your errors from your public library. Let's say your puzzle library uses someone else's fractal library to generate a pretty image for a puzzle. If that fractal library returns a fractal error, should you pass that error back to the user of your puzzle library? No, definitely not. Your users should only get puzzle errors. So what you should do instead is to convert that error into a new variant of puzzle error and return that. You don't want to pass through errors from external dependencies because, one, that gives the external dependency the ability to break your public API, and two, it prevents you from changing your own library's backend implementation without breaking your own public API. Now, there is one exception to this rule. When you receive a standard library error or some other common ecosystem error, it might make sense to pass it straight through. Let's say your library function deals with opening puzzle files on disk. It might make more sense to pass an I/O error from trying to open a file straight through to your user rather than wrap it in your own error. Or it might not. You need to use your best judgment for that. Another example, let's say that you're doing asynchronous code and you're using the Tokyo runtime. Maybe you're dealing with a common Tokyo error. Well, if the user of your library is also using Tokyo and they're expecting to be dealing with errors at that level, you might want to pass that straight through. Again, you need to use your judgment. Number four, your enum should be non-exhaustive. It looks like this. Super easy to do. Just add the non-exhaustive attribute right above your error enum. Why do we do that? Because we don't want to break users' code. The non-exhaustive attribute makes it so you can't do a match expression without a wildcard. So this match expression wouldn't compile. This is a good thing because if we allowed matching without a wildcard, then anytime we added a new error variant, all code that used it, that matched on it, would break for our users. And number one, breaking user code is bad. Users get upset when you do that. And number two, breaking user code also means you have to bump your major version number, and you may have been adding a feature or fixing a bug, neither of which really merits a major version number bump. So a user of our library is forced to always include a default arm for their match expressions just in case there are new variants in the future. Now we can add error variants in our library and not break any user code. Number five, here's the big one. Implement the debug, display, and error traits in that order. Why in that order? Because the error trait is defined to be a subtrait of debug and display. Or in other words, you have to implement debug and display to be able to implement error. So let's get started by implementing debug. It's the easiest since it can be automatically derived. Just add the derive debug attribute, and you're done. One trait down, 2 to go. Next up is the display trait. Display is not in the standard prelude, so we'll need to import display from standard format along with a struct called formatter. The trait implementation block starts in the normal way, impl display for puzzle error. There's only a single method that needs to be implemented, the format method. It takes a mutable reference to a formatter, which is why we need to import formatter. I import all the variants of puzzle error into the local scope of the method just to make my next lines fit on the slide better. There are only 3 situations where it's idiomatic to use an asterisk in a use statement, and this is one of them, when you want to bring all the variants of an enum into local scope. The actual implementation is a match statement with a branch arm for each enum variant that writes a string to the formatter describing that variant. And that's it for the display trait. 2 trait implementations done. Now we can finally implement the error trait. This part isn't hard. First, we import the error trait from standard error because this is another trait that is not in the standard prelude. And then we implement the error trait for puzzle error, which doesn't have any behavior that we're required to implement. You'd think that there would be a derive macro for the error trait, given it's so simple to implement most of the time, but nope, there isn't. Don't know why. Here's all the code for our error. Let's go over the 5 things to remember. Number 1, our error type is an enum. Number 2, we've grouped our errors into variants of as few enums as makes sense. In this case, it's just the one enum. Number 3, we're not directly exposing anyone else's error types. Number 4, we've added the non-exhaustive attribute. Number 5, we've implemented the debug, display, and error traits. Now, I don't know about you, but step number 5 seems like a lot of work to me. Look at what we have if we remove step number 5. I mean, that's a lot more concise. But it's also not yet a usable error. The question is, can you find an easier way to do step number 5? Yes, you can. Number 5b, use this error. Let's take a look at the this error package. First, of course, we need to go to our project's cargo.toml and add this error as a dependency in the dependencies section. Or you could just run cargo add this error and let cargo do it for you. Either way is fine. All right, let's start with what we had at the end of number 4. And let's bring this error into scope. This error is a derive macro that will implement both the display and error traits for us. So now we derive debug and error. And this time, deriving error implements both the standard library's display and error traits for us through the magic of this error crate. And we're almost done. To know what string to return for the display trait, we need to add error annotations to our variants. Check out that first template string. To substitute tuple data from the variant into our error message, we can use numerical indices in curly braces. If the variant was an anonymous struct, we would put the name of the struct field in curly braces instead. But ours is a tuple, so I'll change that back. And that's it, step 5b. How about we do a side-by-side comparison? On the left, we have an error using step number 5, that's the manual method. On the right, we have an error using step number 5b, that's using the this error library. These are functionally identical. My advice, do 5b unless you've got special needs, like you're on a little embedded system and you can't afford bringing in another dependency or something. Whew, okay, so that's how you create your own error types. And we will go over an exercise where we run through all this again and make an error type. For now, do we have any questions? And I'm sorry, I'm going to have to bring down the slide in order to see if there are any questions coming in. So let's go over and see what we have in here so far. See, hello from California, what's up? All right, here's a question. Which IDE do you like best for Rust? Okay, I usually use VS Code. That's what I'm going to be using today, so you'll see that. If you like my settings, I actually have a public repository with the settings in there. You're welcome to go take a look at it. Yes, next question. That's not a question. Can you post a link to the repo? Oh, yes, absolutely. So let's see, the link to the repo. So I'll just type it in here, https github.com/cleancut/mastering errors, if I type that right. Okay, drop in any questions, repo. Oh, Arden Labs also put a link in there already. So there we go. I should read ahead a little bit. How do you internationalize error strings? That's a great question. I don't know the answer off the top of my head. I've never internationalized error strings. But I'm sure there's some ways. We'll have to look into that. If you want to contact me, send me contact me on LinkedIn or something like that. We can answer that later. All right, that's all the questions we had in there so far. And we'll go ahead and move on. Once again, if you do have any other questions, put them in the chat. I will round them up. Okay, let's talk about handling errors. Specifically, handling errors in an application. We can't talk about error handling in Rust without talking about the result enum, so let's take a look at result. Here's the definition of the result enum. It has two variants. OK wraps the value we actually want. Error wraps some error value, which we learned how to make in the last section. The must use annotation makes it a compiler warning to silently drop a result. That's so you never forget to deal with errors. Rust strongly encourages that you always deal with your errors because Rust is a great language. All right, there are two broad categories of errors that we will need to deal with. The first is non-recoverable errors, meaning that there's no way for the program to sanely proceed any further. In this case, we should panic, which is basically the nuclear option. The panic macro crashes the program. It looks like this, or in text form, like this. Just pass the panic macro a message. This is what is called under the hood when you call expect on a result that is an error variant, passing it a message to use when it panics internally. Unwrap is just the same, only without the message. You should only unwrap, expect, or panic if you are certain that there is no other reasonable option, because otherwise, why are you crashing the program? Library authors should never panic if they can avoid it. The same thing goes for methods that call it internally, like expect and unwrap. Don't do it in libraries. Applications can panic whenever they think it's appropriate, but it should still be the last resort. Don't try to catch panics. That defeats the whole purpose. They're not meant to be caught unless you're doing something exotic like writing a testing framework. If an error is recoverable, then you should either handle it or return it. Let's dig a bit deeper into that. The if-let expression is super useful if you care more about the error than the success value. Remember that if-let takes a pattern on the left side. If the pattern matches the value on the right side, then the pattern's variables are bound for the scope of the if-let block. So, if we received an error here, then we're just printing out a warning and then continuing on with our program. Often, though, you're going to want to supply some sort of default value to use if there was an error. So in that case, you could use a match expression to handle both the success and error cases and make sure they both return the same type. In this example, if we're unable to retrieve the saved score from disk, we don't even care about the error, we just want the default score of 0. A lot of these situations can be handled by results helper methods, so I encourage you to read through the documentation for result. For example, this match expression I'm showing you here can be simplified to a call to results unwrap or method, which does exactly the same thing as the match expression on the previous slide. Now, what about when we don't know what to do with an error? In that case, we should return the error to the caller to handle. It looks like this. Here, the poem function returns a result whose OK value is a string or whose error value is an IO error. Then, anytime we do something that might return an IO error, we use a match expression that always looks sort of the same. If it's an OK, we unwrap the value. And if it's an error, then we don't know what to do with it. So we rewrap the error in an error variant and return it from the function. This is super, super common. So common that Rust has a special syntax for it. The question mark operator, which is also referred to as the try operator because it began life as the try macro back in Rust 2015. Let's go take a look. To change this code to use the question mark operator, we strip out the match expression syntax, including the match keyword, and replace all of this with a question mark after the result. Do you see it? It's right there after the function call that returns a result. This does the exact same thing as that match expression. If the result is an OK, then it unwraps the inner value. If the result is an error variant, then it returns the error from the function. This makes it super convenient to chain a bunch of method calls that could all return an error compatible with the function's signature. For instance, this is a made-up example of a chain of calls that each have the same sort of error value in their result. In the happy path, each of these method calls succeeds and evaluates to a new value, which is unwrapped, and gets its own method called. The unhappy path is returning early from whatever function this statement is located in. This looks good. I mean, it's pretty readable. We know that either one of these question marks is going to return a transformer error, or the whole chain is going to succeed and return a vehicle. This is really nice syntax, especially when you compare it to the old try macro format. Oof, that's a lot of nested parens. Of course, even that was better than writing it out longhand. Although, to be fair, if you introduced intermediate variables, then it isn't bad looking per se, it's just long and repetitive, like, say, Go code. Anyway, that is why we now have the question mark operator. It's so nice and ergonomic. Systems programmers can have nice things too. But what if you're dealing with multiple error types in your application? In a library, my advice is to handle any error that isn't your own type and immediately convert it to a variant of your library's error type. So in your library, if I can speak, you will be manually handling other libraries' errors until they're converted to your error type, and then you can use the question mark operator for your own errors that are flowing up and down your library's call stack. But what about an application? Do you only get to choose one error type to use the question mark on and have to use match expressions on all the rest of the error types? No, we can leverage the power of traits. Let's make a puzzle game application to illustrate this. There's a manual way to do this, but there are so many pitfalls to warn you about. I'm going to skip the manual approach and go straight to using the anyhow package, which I've added to the dependency list. There are other competing libraries like Air and Snafu, and you're welcome to check those out later if you like. I've chosen to demonstrate anyhow because I feel like it's the most mainstream choice right now. Oh, we'll also need our puzzles library that has the puzzle error type that we defined in the last section. Okay, here's our main.rs. Anyhow has a special result type. This result type does all the right things with the error trait in generics to make it so it works well with any kind of error. We'll be dealing with a puzzle struct that I go over in my Ultimate Rust 2 course. So let's import that too. And we need to read a file, so we import standard file system file. Now that we've taken care of those imports, let's make a function called getPuzzle, which takes a file name and returns a result wrapping a puzzle. Puzzle struct is another struct that I went over in Ultimate Rust 2. All right, note that anyhow's result has hard-coded its own special error handling. That's the whole point of the library. So you only need to specify the OK type in the result. Our OK type is puzzle. The error can be any type that implements the error trait. The first thing that we're going to do is open that file. That might fail, so we use our question mark operator. This is where the magic begins. IO error implements the error trait naturally, so the anyhow result will accept it, which is convenient for us. But the convenience doesn't stop there. Anyhow has other helpful things for us to use as well. Let's go back up to our anyhow import at the top and add the context trait. Bringing that trait into scope allows us to use the context methods on result to add bits of context about errors that may occur. This is sort of like how we can use the expect method on normal result enums to crash the program with a bit of context, only without the crashing and with more sophisticated handling. Let's say we want more than just this hard-coded context. Can do. Using the with context method, we can pass in a closure that does something fancier. The closure will only be called if an error occurs, so we avoid the overhead of allocating and formatting the string in the success case. Next, let's use that file handle to read in the data and convert it into a puzzle. I didn't show you the from file method before, but it takes a file handle and it returns a normal result with either a puzzle or a puzzle error that we just spent all that time defining in the last section. We've got two different errors in play, an I/O error and a puzzle error. In both cases, we don't know what to do with them in this function, so we're passing them up to the caller to decide what to do. We're using anyhows with context and context methods to add some useful information about the errors we may hit. Finally, if everything was successful, we just return OK with our puzzle. This function is pretty robust. Things can go wrong, but if they do, we just pass the error up the stack for someone else to worry about. In this case, it's going to be our main function. The main function can also optionally return a result, because result implements the termination trait. So I've chosen to return one of anyhow's results, wrapping the unit type, which is just empty parens, because we don't have anything useful to return in the success case. At this point, our quote-unquote game is just going to try to load the puzzle. Once again, I've added some context and used the question mark operator. In this application, nobody's going to handle the errors. We're just going to pass them all the way out. If we don't hit any errors, we'll print out the name of the puzzle and exit successfully. But we're going to hit errors. Let's go check it out. I'm going to run this without a puzzle.dat file so we can see the I/O error. The first time we do cargo run, you may notice why some folks decide not to use these extra libraries. It pulls in more dependencies, which means longer first compile times and slightly larger binary file sizes. But it sure is a lot more convenient. Let's focus on the output here. The anyhow library provided this output for us automatically since we returned an anyhow result from the main function. We could have printed this out ourselves from inside the program if we'd chosen to, but this is a convenient way to get the error output for our small example. There are 3 levels of context here. The outermost level of context is at the top in this error section. If you remember, this is the context we provided in the main function itself. Couldn't get the first puzzle. Then we have the caused by section that lists a chain of all the rest of the context. If you only have one error in your chain, then it won't even have this section. It'll just have the top message. But if you have more than one error in the chain, then it adds this section and starts listing them out. So at the top of the rest of the stack is our message from our function, including the file name we inserted into the context string. Couldn't open the puzzle file, puzzle.dat. But where did that final message come from? No such file or directory. Anyhow grabbed that out of the I/O error itself using its display trait. We just traced our error from the highest level of error handling down to the lowest. That's pretty cool. We've got a lot of context here to help us understand what went wrong at each level in the call stack. Let's add a puzzle.dat file and try it again. After putting the file in place, I do cargo run again. It doesn't need to recompile anything, so there's a lot less output. What did we get this time? The same top-level error, which isn't surprising. Next, we see that we couldn't convert the data into a puzzle. Okay, so we were able to open the file, but we couldn't convert the data into a puzzle. Why not? Because we were missing a piece. Remember that variant? Why is it always that one piece that's missing? Anyway, as a bonus, if you use the nightly build of Rust and set the right environment variables, you can also get access to the full backtrace, which is difficult to do without anyhow, without crashing anyway. Actually, I'm wondering if we can get access to the backtrace in stable version of Rust. Yeah, I need to check and see if that's hit stable. Okay, and that is the end of our handling error section. So let's go double check and see if we have questions. Oh, this time, I don't have to show you a blank screen. I can show you me. Let's see. Camera controls. There we go. Hey, everybody. So let's see if we got some questions here. Let's see. Why can we access tuple error like this? OK.0. Sorry for the... Okay. You mean why can't we access tuple errors like OK.0? You know, I'm not sure what you're asking. So I think, are you asking, can you put the name and the dot and then the 0 in the macro? If that's the question, it's because we don't have a variable at that point. We're on the type. So we only have access to the fields. We don't know the name of a variable. So it'd just be the... If that doesn't answer your question, please ask again and clarify, and we'll keep going on that one. Next, let's see. Let's see. How to marry my error type and some other errors like IO error in the result. Let's see. How to marry my error type and some other errors in result. So I think, are you... Okay. It sounds kind of like, are you asking how do I handle multiple different error types in the same function? And my recommendation was to use something like an anyhow result, which will generically accept anything that is an error, that implements the error trait. Again, if that's not answering the question, please clarify and we'll dig deeper. Okay, next question. When should one use the question mark operator versus custom error handling with match or if let? So you should use the question mark operator in that specific situation where if it's an error, you want to return it from the function. And if it's a success, or if it's an okay, then you want to unwrap the value. So that's specifically what you use the question mark operator. If you want to do anything else, then maybe a match expression will work better. Like, let's say instead of just unwrapping the error, you wanted to, I don't know, process it before you get the value, then maybe you want to use a match expression. Or if you don't want to return from the function, then maybe you use a match expression. So yeah, good question. Let's see. Someone is commenting that they use from trait to convert from other errors to my error type. Yes, that's a good point. You can implement the from trait to convert to other errors. Let's see, another question. What advantages does adopting anyhow bring to error handling when it seems to trade away the explicit type-safe guarantees of custom error enums, pushes towards stringly typed failures instead? I mean, I haven't felt like it pushes me towards stringly typed errors. I mean, I showed you my error construction, but I guess, you know, maybe it does. I mean, the advantage of adopting anyhow, in my experience, is just convenience. Like, it does a good job of doing all the right things to handle things generically, and then it adds useful things. Like, I showed you the context methods, but there are other like helper things in the library that just make things ergonomic to use. So I guess my answer is the advantages to using anyhow is convenience. Can you do it all yourself without anyhow? Absolutely, you can. You just need to do it all yourself. So pros and cons. It would be, you know, if you do it yourself, then it's tighter, right? You're going to have less things. You're not going to have extra dependencies. You're going to know exactly what you did, but also it's only going to do exactly what you did. There's not going to be, if someone else comes into your code and reaches for something that anyhow has, well, it won't be there. So trade-offs. Next question. Can we integrate anyhow with observability stack, e.g. sentry tracing, so that context data is visible as structured metadata? Yes, you can. But I'm not going to go over how to do it in this webinar. But yeah, the answer is yes. Next question. Let's see. Some cross answering, which is fine. Some discussion. Okay. Considering anyhow, should we consider as a good practice always providing a context before propagating errors with the try operator? Is there any disadvantage by doing so. I mean, the disadvantage is it's more code. The advantage is you get all of that context. So, I mean, as long as, I mean, there's the visibility aspect to look into. Are you getting like, is this going to crash and you're going to see like the output right there in the terminal? Do you have access to it somewhere? Is it going to go to Splunk? Is it going to go to Sentry? Is it going to, like, if you have access to it, my answer would be like, yeah, I feel like it's super useful in general, but maybe not, right? In specifics, like if you've got that endpoint error, maybe you don't care how it got there. I guess it's really context dependent. Sorry for the pun or the overuse. Right? If that end error gives you enough information to go off of to like know exactly what went wrong, then you don't need any context in the middle layers, right? So it depends. Do you need to know what happened in the middle layers? Like some complex applications, there's a lot going on, and maybe every layer down the call stack is doing a lot of fiddly things and touching a lot of stuff. In that case, I'd say definitely add your context all the way down. And there's other designs where it's like, oh, there's really not a lot of middle layers. It's like, I don't know, a proxy or something. And like, you just need to know like, oh, the HTTP response really says it all. In that case, you don't need it. So, it depends, like the answer to a lot of things. Next question, let's see. Is there any pattern in a Rust app to catch all errors and process in one place? I'm going to answer this as if you asked, is there an idiomatic way or a commonly practiced way to catch all errors at one place? No, there's not. Is it possible to make a way? Yes. Is there like an idiomatic, like, this is the way we usually do it and we catch all things like in the main and like just let things bubble up to it? No, this isn't a scripting language. Rust is very explicit about, hey, you got an error from this specific function call, you should handle it immediately. And I feel like that leads to much better designs, much better handling. It's a lot less crazy. I have a lot of experience with Python monoliths. I have some experience with Ruby on Rails. They drive me crazy because you'll get these exceptions that were not caught anywhere, and you're just dozens of levels away from wherever it happened. You finally receive it, and you're just like, okay, this is why all the way up here? Like, it should have been handled way down there. And in a lot of the cases, the answer is, well, I didn't know that exception could occur. So, whoever wrote it didn't know the exception could occur, so they didn't handle it. And that's kind of the way that we develop in those scripting. At least the way I developed in Python. And whenever I called something, I didn't think, okay, what are all the possible exceptions that could ever be thrown by this function and anything that it calls down the stack? But in Rust, it's just explicit. Well, this function can return an error, therefore, handle it right here. All right. Next question. Can we use ? For every kind of error propagation, or it works for a specific type of error? So if you use it with an anyhow result, you can use it wherever you want, and it will propagate anything that implements the error trait. As someone else mentioned, if you want to manually say, well, I only return this one error type, that's my error type, but I'm going to implement from the from trait so that I can convert other errors into that error type automatically, then you can use the ? For that as well. So yeah, good question. Next question. Would you use anyhow in a library, or is it better to stick to converting errors yourself? I personally would not use anyhow in a library. I feel like that's kind of an application concern. Now, does that mean no one does? No, I think some people will. But like if you return it from your public API of your library, then you're making anyhow part of your public interface, right? That I recommend it against passing errors from other libraries through your library to your user. For the same reason, I would recommend against using anyhow's result type in your public API, because then you're dependent on anyhow. If anyhow makes a break and change, people have got to also use anyhow once they use your library. Like, you're tying into an ecosystem at that point. I feel like that's not worth forcing people into. Maybe they don't want to use anyhow in their stuff. So like if you wanted to use it inside your library below the public interface, then fine. But like then you're like dividing into like using it here but not there, and I don't feel like it's worth it. But that's a kind of my style choice. So my recommendation would be use anyhow in applications, not libraries. But you can try it and see. Maybe your mileage will vary. Let's see. Next question. Got any tips for beginners learning Rust? Absolutely. Go take my crash course. It's literally just all the tips for getting up the learning curve so you can get started and know how to learn Rust. Like that's the hardest, and that's one of the reasons I got into teaching Rust, is because teaching at the time there was 0 courses. There was 1 book. That was it when I got into Rust in 2016. And I was like, this is so hard to get up the learning curve. And so I started teaching it just to help people get up the learning curve. Yeah. So both of my courses have all sorts of tips. My crash course is focused on, like I said, fundamentals that get you up the learning curve, the ownership paradigm, structs and basic types, and like how the language works and cargo and all that kind of stuff. And then my Ultimate Rust 2 is like, okay, you're a professional programmer. You want to join another team where they're all professional Rust programmers. What do you need to do to like fit in and be idiomatic and like do good practices and not look silly? So yeah, that's what my courses focus on. Let's see. What open source repo do you suggest or recommend to explore and understand error handling approach in Rust with anyhow this error? I'm looking for recommendations. I don't have a go-to where I say, go look at that repository. I'd say go to any of the big ones, and they're going to have good examples. Like go to any popular crate and just check out what they do. Same with applications. Just go to some of the applications and see what they do. And it's interesting. You'll see different styles. You'll see different choices. You'll see different, like, someone may choose to use snafu instead of anyhow, or is that the this error level one? I can never remember. I don't use that one. You'll see different approaches, but definitely reading code is always helpful, always instructional. Let's see. Next question. Is the crash course in the repo posted above? No, the repo is specifically for our exercise, which we're going to run through together for just errors. There's an Ultimate Rust 2 repo. Here, I'll just put it in the thing. It's https github.com clean cut /ultimate rust 2. That's the repo for the entire course that the errors section is pulled out of, and it's got exercises for all the sections, so you can look at that, kind of get a preview for like, oh, this is the stuff we'll be learning and stuff like that. The crash course, oh, hold on, you asked about the crash course. The crash course repo. Now go to Arden Labs to actually get the courses, ardenlabs.com, but the Ultimate Rust crash course repo, I put that link in there as well. Yeah. Anyway, next, do you have any tips for getting deeper understanding of Rust while not being able to use it at your day job? I was in that exact situation. For me, I found it super helpful to start teaching other people because that forced me to learn it. Also, just using it. So if you don't know how to get started, my Ultimate Rust 2 crash course makes use of my my Rusty engine, simplified game engine that's focused just on learners that are learning Rust to have something to do projects with. That's my real recommendation, is use the Rust. How do you learn it? Use it. Use it in personal projects. If you go contribute to an open source Rust project or something that you actually use or something. You need to use it. If you don't use it, you won't learn it. And I made the Rusty engine so you could have like a simple API, a simple library to use to do something interesting and visual, that you could put up graphics on the screen. You could move them around and control them with your keyboard or your mouse or whatever, and you could play music and do events. And I don't know. In my experience, about 50% of all developers everywhere want to make a game anyway as like a side project or a a goal. That's where they eventually want to end up, is making a game. So I thought, oh, that's a great learning tool. At least it was for me. I just make little game projects, run through scenarios, make a game that does this. And it's all about, okay, well, I know what it looks like to succeed because I will have something that does what's described. So now I just need to use the Rust to make it happen. And it's a simple way to do it. Next question. Let's see. That's a comment. Arden Lands dropping some stuff. Good. Do you have any? Oh, did that one. Some more comments. So I'm wondering how you know you're ready to leap from personal to professional. Oh, that's a highly personal choice. I mean, I lean towards being aspirational. I feel like if you're excited about something and you've proven a base level of understanding, go for it. Especially like if you're already a software developer, you're already a professional, learning another language is not a big leap. And if you do some personal stuff in Rust and you want to switch to a Rust role, I would do it earlier rather than later. Because then it's really that being forced to use it on the job that gets you the real experience and really gets you going. So yeah, my recommendation is earlier. Do it sooner. Do it when you're still uncomfortable. Next question, let's see. I'm struggling to read documentation from OOP trait, aka interface used to have prefix separate or separable. I'm sorry, I don't understand the question. If you could reword it or clarify, that would be fantastic, and we'll go over it again. That's the questions. Let's go over our exercise now. So, we got another late breaking question. Hey, I'm a DevOps engineer trying to move into Rust development. Well, where'd it go? Can you delete on this chat? Okay, I'll come back to it when it reappears in the chat. Oh wait, there it is. Sorry, I probably just scrolled or something. Trying to move into Rust development. I've written some small tools in Go, but I've never been a full-time developer. Any tips on making that jump? Oh, so first-time development. It's similar. Go for any job you can get. Like literally, just get any job that gets you experience. The software engineering careerosphere, the working place, they care about experience, right? So when you're getting your first job, list your experience playing with stuff. Like literally say, I've played around with this, I've played around, maybe not say the word play, but like I've done on my own time, volunteer projects, I've done this with open source, I've tried this out, I've tried that out, and go for any entry-level job that will let you use the technologies that you're interested in. Get a year or two under your belt, and then you can use that as a launching pad to get another job in the same area, or you can build on it and say like, okay, like I know this, and I on the job I also learned that, and on the side I learned this, and put it all together and apply for something that's more appropriate for that collection. That's what I'd say. Go for anywhere where you can get that first job, because that's the hardest part, is getting in initially and getting some real experience. After that, it becomes easier. I wouldn't say it's easy. It's rarely easy to get jobs, but that is the hardest part, is getting that first job. Okay, let's go ahead and do the exercise. I'll come back to questions. In fact, I'll try to like periodically look and see what we've got going on. Let's do camera. Let's do a front camera. Okay. Hey there. Okay. Let's clear this up. So what we're going to do today's exercise, so I'm going to clone the repository. So git clone, git github.com using SSH, clean cut / which one are we doing? We're doing mastering errors. Okay, I'm going to open up in VS Code because that's what I'm using today. There's a lot of other good editor choices. Feel free to try them all out. I'm particularly intrigued by Zed, the Zed editor. Sounds really cool. I know a lot of people are having fun with Cursor. Let's see. Okay, so we want to go to, let's make this bigger. Presentation mode, bigger, open the side. Okay, we're going to source lib.rs. That's where we're going to start. So here's our instructions. So we've got this library. I've got a bunch of stuff already kind of stubbed out. We're just going to be fixing up this library, making it work. So we're going to create a dolphin error type representing the following three conditions. Hungry, the dolphin is hungry. Too young, the dolphin is too young. And long name, the dolphin's name is too long and annoying to say. Now, why are we making this error? Let's go look at some of the existing code. When I go through the course, I kind of build this up a little bit more gradually. So let's go over, what do we have here? We have this dolphin struct. So dolphins have a name and age and whether or not they're hungry. And then we have these these methods implemented down here. So there's this say your name, but it might have an error. Right? It might have some kind of dolphin error. And if we look at the implementation here, if the name is longer than 10, if it has more than 10 bytes in it, then we say, okay, dolphin error, long name. It's just too long. Otherwise, we'll return this message. Hi, my name is whatever, and I'm a dolphin. And then similarly for flip, if they're too young, then they can't do a flip yet. So return an error. Otherwise, they say, okay, I'm doing a flip. So these all return strings describing something in the success case. And then here we have shake hands, and we say, oh, if they're hungry, they can't shake hands with an audience member. Otherwise, they can. So this is kind of we want to use that. We assume that these errors exist, but we haven't created our error yet. So we have an existing need. So let's go down here and uncomment this kind of placeholder. So it's a public, so we can access it from outside the library. It's an enum. It's named dolphin error. We need some curly braces for an enum. Okay, here's our reminder for our 5 guidelines, because that was a lot. I mean, those 5 things, it's a lot to remember. So first off, we need to use an enum. Check. We got an enum right here. Okay, number 2, your error conditions should be enum variants grouped in as few enums as makes sense. Okay, well, we can just put all 3 in this one because they're all dolphin errors. That's fine. Number 3, don't expose error types other than your own. Okay, that's not going to be a problem. We're not doing any I/O or anything. But if we were, we would want to like wrap it or something. Probably. 4, make your enum non-exhaustive. Okay, so that's the non-exhaustive attribute. Okay, we did that one. Number 5, implement the debug display and error traits, or 5b, we can use this error's error macro to derive the display and error traits. So let's check and see if we've got those. Oh, look at that. This error anyhow, they're all ready. So they're already there. So that's great. Let's do 5b. That's just so much more straightforward. So we've got the hungry, we've got the too young, and we've got the long name. Okay, so this error doesn't implement debug, so we still need to do that. So let's go up here and go derive debug. And then this error macro, derive macro will do the display and the standard library error trait for us. So we'll put error here. And I'm going to click on this. That will add the use statement to bring it in from this error. So there, it added the use this error. And so that's the derive macro we're using here. Okay, that's close, but if we save that, we should see, okay, we're not quite there. We're not implementing display yet because we didn't annotate these variants with what to display. So we do that with an error annotation. So, okay, we're going to say error, and what's the error? Okay, so for hungry, let's just do this to say the dolphin is hungry. And then for too young, we'll go error, the dolphin is too young. And similarly for this one, we'll error, the dolphin's name is too long. Okay. Now if we save, we should see, okay, it's all happy. So we've done our entire error type. We've got a workable error type. So I'm going to pause and see if there's any questions up to this point here. Let's see. Helpful advice. Get some comments. I don't see any other questions yet so far, so we'll keep on going. Okay, so once we've completed defining this, you should be able to build just the library without any errors or warnings. So let's go give that a try. So cargo, build just the library. Great, no errors. So good stuff. So we looked at this whole lib.rs file. We went over the struct, we went over the methods, and that's all there is here. That's lib.rs. So now we'll go over to main.rs for our next portion here. Okay, number 2. We already did number 1 in lib.rs. Yes, we did. Number 2, uncomment and finish the playtime function below. Okay, let's go ahead and uncomment it. bring anyhow result into scope with a use statement. Okay. Use anyhow result. Okay, have the playtime function return a result of a vector of strings. So result of vec of string. Okay, so it's going to be this vector of strings in the success case, and some type of error, any type of error that implements the error trait in the error case. Okay, the vector of strings will represent successful outcomes of various dolphin tricks. Remember, all of those dolphin methods return strings, so we're going to call various methods and collect them up in some vector. In fact, it's right here, responses, a vector. All right, 2b, call the say your name method on dolphin. Use the try operator to unwrap the value and push the value onto the responses vector. Okay. So we could use intermediate variables to do this. So let's go ahead and try that here. So we've got our dolphin that's passed in right here. And we want to call the say your name method. Okay, now it might return an error. If I just leave it there, it's returning a result string or dolphin error. Oh, got to turn off that pop-up. But what we want to do is get that thing, get the value. So we'll unwrap it with the try. Now you see that that's just a string. And if it was an error, we returned it as the error of that result. Okay, and then we can push on that result. Okay, so that's one way to do it. We're going to do the same thing for the flip method. We could do that all in one line. We don't have to make an intermediate variable. So we could go responses, push, dolphin. Which one is this one? Flip? Yeah, flip. Okay, and right here, we put that question mark operator. So right here, it'll call that before it calls this push. And if it's an error, it'll actually return right out of the function, ignoring the rest of the function down here. So that works just as well. Same thing for shake hands. So responses, push, dolphin, shake hands, question mark. Okay. Now in the success case, we've pushed 3 strings onto this responses vector, and then we returned an OK with that vector, right? The vector of strings. In the error case, we return some error from one of these method calls. Okay, so we should, I think, be able to build now. Cargo build. Oh, nope, not yet. What did I do wrong? Oh, that's called response, not result. Build. Thank you, helpful compiler. All right. Did that. Let's go down and look. Okay, so down here we have our main function. Let's close this real quick. So we've got this vector of dolphins. So we've got Augustinius here. He's 7 years old, or 7 old. I don't know if it's years. He's not hungry. And then we got Biddy, who's 2, who is hungry. Carson, who's 5, and he's also hungry. And Devin, who's 6, he's not hungry. Okay, and then down here we loop through each of the dolphins, and we call that playtime. And then if it's an OK, then we print out the name of the dolphin and that they did a fabulous performance, and then loop through each of their responses in that vector of strings and print them out. A little bit indented. Otherwise, we print out an error. So let's go try it. Cargo run. And there we go. Augustinius can't perform today. The dolphin's name is too long. So the first dolphin that was passed in was Augustinius here. Right, we hit over in lib.rs, say your name. Oh, the name was longer than 10 bytes. So we had an error. We returned that, and we printed that out. Same thing for Biddy. Biddy is too young. Carson is hungry. But Devin met all of the criteria. He actually returned success. He did a fabulous performance. We looped through the vector of strings, outputting them all, and we were happy. Let's see if we have any other questions at this point. Let's see, is there any Clippy lints that we should be aware of when talking about better error handling? For example, I'm a fan of Clippy unwrap in result, but eventually there are other useful rules out there. Oh, I mean, Clippy in general is just super useful. Let's go see if we have any Clippy warnings. Cargo, Clippy. I go over how to use Clippy and all sorts of stuff about Clippy in Ultimate Rust 2. Okay, so here we go. Look at this. Useless use of format here. We're doing format. We're giving it a template string, but then we're not giving it any variables to substitute in. So boom, Clippy's helping us out. So let's go take a look at it over here. Boop, boop, boop. Clippy. Where's our useless one? Oh, yes, right there. Boom. Let's take this out. They don't have any template variables. Run Clippy again. Interesting. This argument influences the type of okay. Anyway, you can see that. Uh-oh, we wanted to have a string. So now we got to go into. Anyway, and you can follow that up and get it all done. And what do we got? Allow vec init and then push. You forgot a. Oh, that's funny. That should have that right there. No, there? Okay. Why is it not happy with what I did? Anyway, Clippy's great. Tells you to do all sorts of stuff. I'm going to undo. So we're just how we were with the... No, that's way further than I thought. Is that because we're in main? I was trying to undo this. Just put it back how it was. Okay. Do I need to redo in here? Push response. Are we running again? Okay. Whew. There we go. I don't have any like specific Clippy lints to call out, although I would call out that there is a website that lists all the Clippy lints, and if like me, you're a fan of reading dictionaries or encyclopedias because it's super interesting, you can read through all of the Clippy lints, and it's kind of like a book of tips and tricks. It's like, don't do this, do that instead. Don't do this, do that instead. You can actually just read the description of all the lints, and in all the lints, they have an example of like, here's what you shouldn't do, and here's what you should do. And it's like super good reading, super good reading. In fact, like, I think it would make a nice, just like book, like dead tree book. Okay, let's see what we got left in here. And there's a challenge exercise. Now in the other courses, I don't have time to go through all the challenges and stuff like that. I don't actually have a hard limit on the time for this webinar. So let's go ahead and just do the challenge before we end. So I'll just go a little bit longer. If you have to go already, that's fine. You can come back and catch this recording on Arden's YouTube channel later and catch back up. For those of you who can hang out, let's do this challenge real quick. So change main so that it returns a result, and instead of handling the error that playtime returns, use the try operator to only handle the success condition. Okay, if done correctly, the output of the program will become much shorter, since playtime returns an error variant the first time it's called. The try operator will return it from main, which will end the program at the first error. Okay, makes sense. So let's do that. We're saying, okay, main itself will return an anyhow result. And we'll just have it return unit type. Now that means that at the end of main in the success case, I'm going to say, okay, here's an empty unit type. Okay, now in here, instead of handling this, we're going to say playtime. Let's see, we need to get the responses. So let responses equals, call that and just do a question mark. And then we can take off all the matching and stuff and take off the error handling. And let's see. Responses, is it this one? There we go. So now we just do it once. Now if there's an error, we're going to return out of main. Now this works because anyhow's result implements the termination type, the termination trait. And in that trait implementation, it takes that error and it prints it out. So let's go give that a try. So cargo run. Now you can see this is anyhow outputting the error colon. And then there's the error. The dolphin's name is too, oh, I undid so far that I didn't have long on there. It's too long. Okay, let's go a little bit further. Like, let's see. Before we do that, let's add some context. Let's say, okay, context. we can't do playtime, or something like that. Go add that, and we'll see. Oh, okay. If we're going to add that context, then we have to import the trait that comes from. Import the anyhow context trait. So click on that. That did it right up. Where did it do it? Somewhere. There it is. Anyhow context. So I added that line. Whoa! Sorry about that. Okay. Try this again. Cargo run. Okay, so now we've got this top level. We can't do playtime. And it kind of shoved our... Now that we have a chain, it started this caused by... Dolphin's name is too long. So that's kind of fun. Anyway, see if we have any other questions or anything. Don't have any questions. Okay, so that was kind of our challenge. And then, of course, like if this is a real application, we go through and be like, oh, well, let's go fix these errors, right? What's wrong with this guy? His name's too long. Well, let's fix that. Oh, now this other one's too young. Let's get an older dolphin, and so on and so forth. Oh, he's too hungry. So fix it all up. Can we get to the success? Ah, there we go. They all succeeded now. So fun stuff. Okay, so let's go ahead and finish up. Let's go to 6K only. Questions, not questions. Hey, where did it go? Come back. Keynote. All right. Did the exercise. All right, we're all done. So now what? Well, if you liked this little webinar, there's a lot more just like it in my Ultimate Rust 2 Intermediate Concepts course, which I teach through Arden Labs both live, in person, or remotely, or on a pre-recorded video course that you can take at your own pace. We covered just the error handling section of that course today, just the error handling section. But there's all sorts of other topics that we dig into and we learn about. And even better, there is a Black Friday sale that has already started for 40% off through the end of November. The Ultimate Rust Training Bundle has both my Ultimate Rust Crash Course and my Ultimate Rust 2 course, plus 5 additional courses from Herbert Wolverson. That's 7 courses over 44 hours of instruction, plus projects and exercises. Super fun. Here's let me put up there we go. There's all the information. So that's ardenlabs.com/Black Friday. You can go there for details. Thank you, everyone. You have been an amazing audience today. I appreciate you guys coming. I hope you had some fun. I hope you are feeling a little bit better about errors and that you can go and use that in your own projects. I hope to run across you guys in the future. Thanks, everyone.